Let's solve Unit 4 Database Management System questions. Which of the following command can be used to modify data in an SQL table? When you take insert command, what we actually do is we insert some data inside the table. So you're doing something to the data. This can be considered for the solution. What about delete? You are actually removing the existing data. Again, this is equal to modification of data. So delete is also there. What about update? Update is you are rewriting some value in the record. You can either update a particular field of a specific record, or without any condition you can update more than a record. So definitely in update we have modification of data. What about select? In select you are not going to feed any data, you are not going to remove any data, you are not going to update any data. No work is going to happen with respect to data modification there, but you are going to just retrieve data. Retrieve means whatever is present in the table, that will be given as output. You are not going to do anything in the table, but in insert you are adding one row, in update you are modifying one row, in delete you are deleting that row with respect to a single record I am telling you. So in select we don't do any data modification, we just read the values. So we are going with A, B and C alone as the answer. Option 4 will be the right answer. Next question. In concurrency control, phantom problem may occur when? Actually we have come across this phantom problem in certain previous year question papers. A situation known as the phantom problem can occur when a new record that is being inserted by some transaction satisfies a condition that a set of records accessed by another transaction must satisfy. During what operation does this situation occur? When a new record that is being inserted. Just look at the options. Records are inserted, records are deleted, records are modified, records are indexed. Phantom problem may occur when records are inserted. Option number 1 will be the right answer. So let's understand about this phantom problem. A transaction T1 may read a set of rows from a table, perhaps based on some condition specified in the where clause. Just take for an example those who are preparing for UGC NET computer science. We are going to retrieve a set of rows. Say for example we are retrieving 5 rows and this is done by transaction 1. Suppose that a transaction T2 inserts a new row R that also satisfies the where clause condition used in T1 into the table used by T1. Say for example this is going to be table 1. In this table another transaction T2 is going to insert one record. Say for example we are going to collect the details of students who are learning for UGC NET exam. So in one particular column we are just going to get the specialization alone. So maths people will enter maths, CS people will enter CS, then English people will enter English. It goes on. So now this T1 is retrieving records who fall under the category CS. There are 5 rows taken totally. Now T2 is inserting one record again for computer science. The record R is called a phantom record because it was not there when T1 starts, but it is there when T1 ends. This is starting in 0.1, this is happening in 0.2 and T1 is ending at 0.3. When it started that particular process, this record was not there. But when it ended up the process, the record is present. So this record is what they call as phantom record. T1 may or may not see the phantom, a row that previously did not exist. If the equivalent serial order is T1 followed by T2, then the record R should not be seen. So once it completes T1 and then it goes to T2, definitely this record will not be seen by T1. But if T2 followed by T1, then phantom record should be in the result given to T1. In case if T2 is going to be executed first and then T1 is executed, then definitely this phantom record R will be present. If the system cannot ensure the correct behavior, then it does not deal with the phantom record problem. Next question. Which of the following table contains the primary information in the data warehouse? In a data warehouse, the table that contains the primary information is the fact table. We'll go with option number 2 as the right answer. Fact tables store quantitative data for analysis such as measurements, metrics, or facts about a business process. They are typically at the center of a star or snowflake schema. These are the terms that are related to data warehousing. If you want to know more about it, you can always explore. And they are related to dimension tables. What are dimension tables then? Dimension table stores descriptive attributes or dimensions related to the facts such as time, location or product details. So here they say fact tables are related to dimension because this dimension table is actually holding the description of those attributes that are related to the fact table. What about lookup table? They are used to map or reference data, often containing a subset of information for quick access and validation purposes. So from this we can rule out dimension table and lookup table. What about primary table? This is actually not a standard term used in data warehousing, so we can rule it out. Next question. An alternate key in database table is also called. What is a primary key? It's a specific candidate key chosen to uniquely identify records in a table. What about candidate key? It's a set of attributes that uniquely identifies a record in a table. What about super key? A set of attributes that can uniquely identify records in a table, but it may contain extra attributes not needed for uniqueness. What about foreign key? An attribute in one table that links to the primary key in another table, creating a relationship between the tables. So they are asking for alternate key in the database table. We know every database table must have primary key. If a primary key is not present, which key can act as a primary key? Candidate key can act as a primary key. Can you place super key in place of primary key? No, because they say it may contain extra attributes that are not needed for uniqueness. So we cannot choose it. Foreign key is actually the attribute which is having the values of another table's primary key. So this can also be not taken as alternate key. A candidate key is sometimes referred to as an alternate key because it is an alternative option for uniquely identifying a record in a table. A table can have multiple candidate keys, but only one of them is selected as the primary key. The remaining candidate keys serve as alternate options for the primary key, hence we have the term alternate key. Option number 2, candidate key will be the right answer. When you are sure about what will take the place of primary key, you should be sure what keys cannot take the place of primary key. Next question. The degree of a relation in database is the number of tuples, the number of attributes, the number of values, the number of keys in a relation. The degree of a relation refers to the number of attributes in a table. Option number 2 will be the right answer. It indicates how many fields or properties each record in the table has. Actually, we are not concerned about the number of tuples. Tuples in the sense the records or the rows you can take. We are not concerned about the count of rows. And what are these values in domain? So if you take a domain of integer, there will be lots of values. That cannot be called as degree of a relation. You can rule out this. The number of keys in a relation. Certain table will have only primary key. Certain tables will have primary key, unique key. So again you cannot have a specific name for it. And the number of rows can be increased, can be decreased using insert and delete operations. So this can also be not called as degree of a relation. When you say something as a degree of a relation in database, that should be constant for all the records. So it will indicate how many fields or properties each record in the table has. Next question. What will be the right sequence of the phases of database design? So this question has been repeatedly asked in 2 of the previous year question paper. Now we will see a diagram relating to it. Requirements collection and analysis is the first step. It is available in D. Then we have conceptual design, which is B. Then we have logical design. This is where the data model mapping occurs. This is given by C. And finally we have physical design, which is A. We have the order D, B, C, A. Option number 2 will be the right answer. So this question has been already explained in earlier question paper solution video. So I am skipping explanation as of now. Which of the following is false statement? Let's start with A. An all key relation is always in BCNF since it has no functional dependencies. A relation where every attribute is a part of candidate key is always in Boyce-Codd normal form, which is BCNF. When we were solving for functional dependencies question of a relation in previous year question paper, when the candidate key is completely present in the left hand side of a functional dependency, then we can say that particular relation is in BCNF. So taking that point into consideration from the previous learning, A is definitely true. We are asked to find the false statement. We know A is true. We can rule out option 1 and 2. Let's go through the B statement. A relation that is not in 4NF due to non-trivial multivalue dependency must be decomposed to convert it into a set of relations in 4NF. When the relation which has non-trivial multivalue dependency is not in 4NF, automatically to convert it into 4NF, we have to decompose it into a set of relation. So this is also true. Now let's go for C. The decomposition removes the redundancy by the multivalue dependency. This decomposition breaks down the original relation into smaller normalized relations that follow 4NF. Other two means we can say it follows 4NF, thereby eliminating the redundancy and ensuring data integrity. So C is also true. From this we can also rule out fourth one. What about D? 3NF is stronger than BCNF. When you take the normal form, we have 1NF, 2NF, 3NF, BCNF, then we go for 4NF. As for this question, I am telling you, Boyce-Codd normal form is actually stricter than third normal form. Every relation in Boyce-Codd normal form is also in third normal form. So only after passing to this stage we are coming here. But not every relation in 3NF is necessarily in BCNF. So when you take BCNF, we can say it is already present in 3NF. Take 3NF, we can say it is already present in 2NF. When you take 2NF, we can say it is already present in 1NF. Every 3NF will definitely be in 2NF. This is how we can say. If that is the case, 3NF cannot be stronger than BCNF. The reverse is actually true. BCNF is stronger than 3NF, we can say. So D is false. Option number 3, D only will be the right answer. But that is the false statement. Here, stronger than BCNF can be taken to be stricter. So here, which is stricter? BCNF is stricter. So this statement is false. Next question. Insert command is used to add a single tuple to a relation, add multiple tuples to a relation, add values to specific attributes, insert new table. In SQL, we have a command called create table. So we can always create a table. We can never insert any table. If you take out D, you can remove fourth option. Insert command is generally used to add a single row at a time or multiple rows at a time. Both are possible. So definitely A and B are in. When we have two options inside the solution, one is also ruled out. Now we have to check whether C is in the solution or not. When using the insert command to add a new row, sometimes we specify values only for certain columns. The rest of the columns will be allowed to take default values. Insert into table name, we can specify column names and then give the values of those columns alone. Imagine there are 3 columns in a table. You can supply values to two columns at a time. That is what they have given as add values to specific attributes. This is only about adding values and not about updating values. Since we can add values to specific attributes similar to this syntax, we can take C also in the solution list. So we can rule out option 2 and go with option 3, A, B, C only as the right answer. To update values in specific attributes of existing rows, the update command is used instead. When you want to overwrite a particular value or replace a particular value, you can go for update operation. But the word they have used here is add. You are actually adding a row with specific values. It means values are given to certain attributes alone. Next question, match the list 1 with list 2. Project join normal form. Fifth normal form is also known as project join normal form or PJNF. A will be mapping to 2. A2 is available only in one of the option. So we can rule out the other 3. Option number 1 will be the right answer. What about the lost update problem? The lost update problem is a concurrency issue that occurs in database systems when two or more transactions simultaneously update the same data item, leading to one update being unintentionally overwritten by another. So what is this lost update? One update is lost because it is being overwritten by another update. The lost update problem B will be mapping to concurrency in 1. B is mapping to 1. What about C? Discretionary access control. DAC is a type of access control mechanism in which the owner or creator of an object, you can take the creator of a file or a creator of a database, has the authority to determine who can access it and what kind of operations they can perform on it. So for what purpose are they restricting? It is for security purpose. So we have C mapping to 4. What about D? Data manipulation language. This will be mapping to SQL. D is mapping to 3. So in SQL we have DDL, data definition language, DML, data manipulation language, and DCL, data control language. A2, B1, C4, D3. Option number 1 will be the right answer. Next question, match the list 1 with list 2. The terms in list 1 are from big data. Hadoop distribution file system. This is HDFS. What is the term in list 2 that is connected to Hadoop? Name node. A will be mapping to 3. Hadoop distributed file system uses the name node to manage the metadata and directory structure of the file system. So this is how we are connecting Hadoop file system and name node. A3 is available in 2 of the options, so we can rule out the other 2 options. What about veracity? In the context of big data, veracity refers to the quality and trustworthiness of the data. So B will be mapping to 1. B1 is available in both the options again. Next we'll move on to Apache Pig. Apache Pig is a high-level platform for creating MapReduce programs and it was developed by Yahoo. C will be mapping to 4. C4 is available in option 3, so we are ruling out option 2 also. What about Apache Hive? Apache Hive is a data warehousing tool that facilitates querying and managing large data sets, and it was initially developed by Facebook. So D will be mapping to 2. D2 is available here. So we are going with option 3. A3, B1, C4, D2 as the right answer. In this channel you have data science series playlist. It's a short playlist with 3 videos. In that if you take the first video you have content about big data. The video is available in Tamil language but the content inside the video are completely in English so that any language person can understand it. With this we are completing unit 4 solutions.